Okay, so Neeraj, we will start with your mock interview. Please tell me your subject.
Okay. Thermodynamics.
Thermodynamics. Okay. Okay. So I will draw a figure and you see here we have a tank, right? We have a tank of
Okay.
water. And
Okay.
and in this tank, first of all, we have this tank is filled with water, right? It is
Mhm.
filled with water, and this tank is very large. Okay. This
Okay.
is a cylindrical tank, right? So
Okay.
we have a this is a balloon. This is a balloon, right?
Okay.
So
Okay.
this is a balloon. This balloon is tied with a string here, right? This balloon is
Okay.
tied with a string here. And initially, this balloon is having a height of maybe small h, right?
Okay.
So first of all,
Okay.
you tell me that if this height is okay, okay. So if this is your capital H, then what will be the pressure inside the balloon?
Balloon is filled with air, right?
Yes, balloon is filled with air. Okay, so let me give you more information. Air, and everywhere
Okay.
the temperature is same, 25 degrees Celsius,
Okay. Okay.
right? Yeah.
Okay.
So what will be
So
the pressure?
pressure inside the air will be H rho g plus it will be greater than H rho g. Basically, it won't be equal to H
So
rho g. It will be greater than rho g h.
okay,
Means
let me
the height
write
at
this
which
height as small a. Now you tell me
it will
what
be
pressure
a minus h rho g. It will be greater than a minus h rho g.
greater than why?
Greater. Because this this can be considered as a soap bubble concept actually,
Right. Okay.
basically.
Okay. So now the
So the
pressure is almost, if I just consider, then
okay,
it is
if we
almost
neglect the tension of the balloon we can almost consider as yeah,
right. Okay. So now
yeah.
what I do is I
uh,
just cut this string. Okay.
okay,
So okay.
okay.
So before that, can you tell me that will this string be tight or slack?
This string will be tight actually
Why?
because there is buoyancy force acting on it.
Buoyancy force. Right. Okay.
Buoyancy.
So now what I do is I just cut this string, and after I
Okay,
cut this string, what will happen if I just cut this string? Then what will happen?
because there will be an unbalanced force actually
Yeah.
because
So
there
what
will
will happen?
be a mass downward acting and a FB buoyancy force acting upward. Since buoyancy force is greater, it will move upward.
It will move
It will move upward.
upward, right? It will
Okay.
move upward. Now consider that it will move to a height maybe uh, h1, right?
Okay.
So
Okay.
draw the PV diagram of the air. Draw the PV diagram of the air inside the balloon
Okay.
from h1 to
Okay.
h2. Draw it.
Okay.
Draw it and show me. Yeah,
Okay.
right.
This one actually. Actually, I am dotted it actually. Uh,
Can you
am
bring
I?
the page a bit of more front to the screen?
Is it clear now?
You have dotted it.
Yeah.
Okay, so what is happening? The pressure is
Act-
decreasing and the
pres-
volume is
Pressure is
increasing.
decreasing,
So you have
increasing.
pressure is increasing,
No, no, pressure is decreasing. Volume is increasing.
decreasing, right?
Pressure is
So
decreasing.
yes, you have drawn it something like this, and actually you have drawn it like a dotted. So why is that?
Yeah. Because when we want to draw something in a straight, matlab, bold lines,
Huh?
it should be always under equilibrium.
Okay.
All state should be under equilibrium at every time. But this is not at equilibrium basically. because there is always an unbalanced force of mass and buoyancy. They are not at matching it basically. So that's why I drawn as a dotted line.
Okay, 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 okay. But if someone says you that you have to estimate the final volume, then how will you do it? You
Mm.
have to estimate. Can you do it
Okay, okay.
to the best possible
Uh,
approximation?
this, okay, okay, okay. So this process is basically a fast process because
Fast
there is
process.
a huge unbalanced force acting on it. So
Hmm.
I can, so even though the material is balloon, there is no time to enough time to have the gradients and have the heat transfer. So we can idealize this process as an adiabatic process. So you can use the equation PV raised to gamma is a constant. Then you can find it.
Okay. So this is your P1, right? I mean, this is your
Okay.
state 1 and this is your state
Mm.
2, right? So consider
Okay.
that this line is your adiabatic line. Now on the same graph,
Okay. Okay.
draw the isothermal
Ah,
expansion. Draw the isothermal expansion
okay.
for the balloon on the same graph.
The one I have drawn above it, above the adiabatic. The
So it is having the same final
below
volume.
one,
It is having the same final volume.
no, it's having same pressure.
It is having the same pressure. So
Same
you
pressure.
have drawn it.
Volume will be different.
Show me, show me. Yeah, yeah. Okay, okay. So you have drawn it something like this. I will also draw. So, right?
Yes,
Something like
yes,
this.
yes, yes.
And these two are having same, same P2.
Oh,
So
yes.
actually you have drawn that isothermal volume is more than the adiabatic volume. The final isothermal volume. Why it is so? Can I
Mm.
explain physically?
Um,
Considering that
because
that air is ideal gas.
because this is process is isothermal process and the pressure is same. Both will have same pressure, but
Right.
the isothermal will have comparatively lower temperature because it got an opportunity to transfer the heat. So it will have comparatively higher volumes.
Lower temperature. So
Yeah, because T and so basically pressure of the both is constant. Pressure is constant here for
right.
both cases.
Hmm.
So pressure is constant and ME mass is constant and temperature. So we can for both cases volume is directly proportional to temperature in both cases. In the case one at the state two and case one case in the state two of case two, both isothermal as well as adiabatic process, the pressure are same.
Yeah. So P2 iso is equal to P2 adia. This is,
Yes.
yeah.
Yes.
So this is you are saying. Then
Then, but what happens in the adiabatic process? There is
hmm,
no heat transfer. So its
there is no
internal
heat
temperature
transfer, right?
actually.
Hmm.
So its
So
internal, its internal. There is no heat transfer. So the P2, the
P2.
temperature two
Hmm.
of adiabatic is less because it has done some work using its internal energy.
So this will be lesser than iso. You are saying.
Yes, 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 yes.
Okay.
Then we have to use the equations basically. When we have to
Which
divide
equation?
it, we have to check like that. PV
Which
sum.
which
Okay,
equation?
okay. PV is equal to MRT, ideal gas equation.
Okay. So use that and I mean tell me the final answer.
P adiabatic into V adiabatic
what will happen to the V adiabatic and V iso?
ISO. ISO. So we'll get as V adiabatic is equal. Okay, sorry. V adiabatic is equal to this one.
Yeah,
V
yeah.
isothermal.
Hmm.
V isothermal into T adiabatic by T isothermal. The term T adiabatic by T isothermal is basically less than 1 because
Right. Therefore,
so V adiabatic will be less than V isothermal.
right. Very good. Okay. Okay. Nice. Nice. Okay. Very good. So now
Thank
consider, I mean, the actual process will be adiabatic, right? I mean,
you.
if we idealize it as a equilibrium one, then it will be an
Okay,
adiabatic
okay.
mostly because it is a fast
Yeah.
process.
Fast
But
process.
now,
Yes.
if I have helium, I mean, instead of air inside the balloon,
Mm.
then can you draw the graph on the same graph? You have to draw it, considering that it is adiabatic only. It is a fast process. If it
Okay.
is helium instead
First
of
it was
air,
air, right?
it was
Okay.
air. Now it is helium.
This one. The
Can you
above one
see?
will be air. Above one will be air.
Okay, so if I draw it here, if I've drawn it something like this, that this is your, is it? So if
Mm,
this is your air,
which yeah,
then
that is air. Yes.
this is your
It will
helium,
have helium will have more slope actually.
more slope.
Yes,
Why?
because it's let me see, it's an monoatomic gas. So its gamma will be 1.66.
Hmm.
So basically the slope is basically minus gamma P by V. That is the slope of adiabatic process.
Right,
So since helium has higher value of gamma, its slope will be more steeper basically in negative direction. That is
right,
why I wrote
right.
helium
Okay,
much more steeper.
okay. So now, what I do is I just take out the balloon. What will be the final,
Okay.
I mean, pressure inside the balloon? It will be
Out मतलब into atmosphere.
no. I mean, at at this height, when it will come, then what will be the
The pressure
final
will be
pressure?
less.
Yes,
Pressure
it
will be
will be
less.
something. I mean,
Less.
A minus
Something.
H1
Yeah.
rho g, right?
Uh,
Okay.
yes. Yes. Yes.
Now
Yes.
consider that A minus H1 rho g is almost like the atmospheric pressure. Okay.
Okay.
So
Okay.
now
Okay.
what I do is I take out the balloon, right?
Okay.
So first of all, you tell
Okay.
me that what will be the temperature? Will there be any increase or decrease in temperature
Since we are
as compared
almost
to the ambient
approximating the
temperature?
this
As compared to the ambient temperature. So I mean,
thing. Okay.
initially everything was in ambient temperature condition. And now we are
Mm-mm-mm.
after this condition, the balloon has risen to this height, and then we are taking out this balloon.
Okay.
Then what will be the
Taking
temperature of the balloon at this height? Will it be more
it.
than ambient, equal to ambient, or less than ambient?
From this side, we are taking out into atmosphere, right?
Mm-hmm.
Yes.
At
Okay.
this
So
condition,
first, okay, okay. Then we are taking
what?
out.
Yeah. So what is the
Okay. Then
temperature?
that means the pressure has reduced basically because it
Pressure
is
has
taken into
reduced.
atmosphere, so pressure is reduced. So and the process is adiabatic because since we have taken out it
Mm-hmm.
and the balloon has done some work actually against the atmosphere by using its internal energy. So
So the
obviously the temperature has to come down. Temperature should come
temperature
down.
temperature
Should
should
come down.
come down. Right.
Mm.
So now, if I
Yes.
just keep it like that, if I
Okay.
just so
Mm.
now I have taken out the balloon into atmosphere, right? So
Uh,
this is
yes.
your atmosphere,
Uh,
and now I just keep it for maybe 1 hour. Then draw the
okay.
PV diagram for that 1 hour. What will happen?
Now the temperature is less than atmosphere. When we kept it in atmosphere, it will gain some heat. And I am assuming the process to be isobaric process because it is at the same state actually. So the volume will increase. So it will be like straight line.
Okay. 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 Neeraj, your interview is over. Okay. Now
Okay,
let
thank
me, give you the feedback. Your
okay,
concepts are very good, honestly. Okay, I have
thank you. Mm.
taken more than 20 interviews for BRC in this year only. So
Okay,
your
okay,
actually
okay,
your concepts are very good. Okay, I
thank you,
mean also compared to others. But the
thank
thing
you, thank
is that
you. Mm.
okay, all the your almost all the answers were exactly right. Exactly right.
Okay,
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 so you can expect exactly same type of questions in BRC. It is
okay,
as
okay,
simple as
okay,
that. Okay. And
okay,
actually, this first question, this was the exact question. So this question was exactly asked in BARC once.
okay,
Okay.
okay, okay,
So you have done very well. Okay. And furthermore, just do the same thing for all the subjects. Okay. Solve
okay,
the
okay,
solve the Quora previous
okay,
year questions and some go for
okay,
some other mock interviews if you want. Okay.
okay, okay.
So do you have any questions?